Alright, so this solution is in a beaker. You sprinkle some salt in there. What or which ion is the common ion? What do you guys think that means? Althea, what do you think common ion means? If somebody has something in common with somebody else, what does that mean?
They have something the same.
They have something that's the same. Maybe the same interests, or the same clothes, or same sneakers, or same, hairdo, or whatever, something. So what's in common here? What does NaCl have in common with this reaction up here?
Na.
The Na, good job. What's ion mean, John Todd? Charge. Here's the ion, Na+. When I put salt in water, does salt dissolve in water? Yes, everybody knows that. Okay? The ocean is a great example. So when you put salt in this solution, it produces Na+ ions. Stay with me. Stay with me. Some of you look like you're fading a little bit. Stay with me. If I put salt in this solution, it will dissolve, and Na+ ions will start floating around. So, Kai, explain what happens. If I add salt to that, I'm essentially adding more Na+ ions. So what happens to the, how do I stress the equilibrium, and then how does it?
It's going to go left.
Yes, very good. Explain. Because this side.
So that side would have more, so it would.
So it's like if I add Na+ to this side.
Yeah, and then it would have to shift.
It would have to shift some of this weight over here to go back to being balanced.
Yeah.
Right? Yes, very good. So the whole gist of this common ion effect, it's a very simple example. It doesn't get any harder than this. Find the common ion, and what this really means is you're increasing the concentration of that common ion. So you're adding more to this side. So if we add more to this side, which we've already learned how to do this last week, if we add more to this side, you're going to be like this. So you have to shift some of your products towards your reactants. So we're going this way. We're going this way. So the common ion effect is actually pretty easy, because anytime they ask it, it always shifts that way. Always shifts that way. There's no other way it could shift, because these are the only two ions involved. It's not an ion. So common ion means you increase the concentration of one of these ions by adding something else, and therefore it shifts it, which means precipitate. You're going to have a lot of solids produced. You're going to see a precipitate because of that. All right? So that's it for common ion. I don't beat that one to death. That's kind of very minimal. Okay? That's it for equilibrium. We're not done with class yet, so hold on, don't pack up. I will be after school every day this week. I do have some AP review going on, but if you need to stay, you want to stay review for the quiz, that's fine. Just let me know so I know you're coming. Some of you definitely could benefit from that. What else? Especially it's the first grade of the fourth quarter. First quiz grade. The homeworks due today were the first grade of the fourth quarter. So I'm after school. What else did I want to say here about that? I guess that's it. So here's what you can do. You can pack up, but we're gonna have a discussion about organic chemistry to see how much we know already. So go ahead and pack it up. Yeah, because there's a sensor back there, and if you don't move around, they shut down a little bit.
Does that happen like every day and I don't notice?
It happens every day. It's every day.
Pretty much. Now, stay with me. Give me a couple more minutes here. Who's it going to be? Michaela. When I say organic, you think nature. Good. Anyone else think of something besides nature? Carbon. Good, Liam. I want you to.
Carbon.
Well, that's what I want you to think. Because when I say organic, what I think of is organic food. That's what I think. But in class, in chemistry, in school, what I want you to think, when I say organic, you think carbon. When I say organic, you think carbon. Any substance with carbon in it, carbon dioxide, is called organic. So water is not organic. Why? Because it doesn't contain carbon. So organic chemistry, all it is is basically taking that element with its 4 valence electrons and seeing how many different reactions it can make. And there's a lot of them. So we're going to learn about all the different types of organic compounds. The reactions we'll probably do in lab mostly. But in lab, we get to play with molecule kits. At least that's kind of fun. I think it's kind of fun. It's better than just listening to me go over homework. So you're going to be putting together these strings of carbons, and you're going to make shapes. You're going to have to name them. You're going to have to draw them. So you're going to learn how to name carbon structures, draw them, and then see how they react. And we do a lab. I'll stop there. Have a good day. And I am after school if you need help with anything.